My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 264. In this lecture, I will continue my discussion on Amazon Fine Food Review data set. In this lecture, we will try to understand TF IDF. I request you to go through lecture number 257, where I introduced this concept so that you can understand what is this TF-IDF. Now let's look at TF-IDF. Just like bag of words computing, TF-IDF is very simple. There is actually TF-IDF vectorizer is again in scikit-learn. Just see scikit-learn dot feature underscore extraction dot txt TF-ID vectorizer, isn't it? Again, it is in scikit-learn. I strongly recommend to go through this documentation, that is documentation of TF-IDF vectorizer. Just the way we did for bag of words, it also has n-gram underscore range. Just see, this is n-gram underscore range, isn't it? I am giving 1, 2. If I give 1, 2, I already explained in my previous lecture. What does it mean? It works for unigrams, even it works for bigrams, isn't it? That's what we discussed in my previous lecture, that is in lecture number 263. Here, let me explain the simple code before understanding this code. Just see this one. These are the simple functions. What are these functions? What is the meaning of fit? This one is fit. What's the meaning of fit? It learns vocabulary and IDF from training set. This you must understand. We will make use this function. What is the meaning of fit? It learns vocabulary and IDF from training set. That's the meaning of fit. There is another function known as get underscore feature names. What's the meaning of this one? Array mapping from feature integer indices to feature names. We will try to make use these names. There is another function known as transform function. What is the meaning of transform function? Transform documents to documented term matrix. We will try to understand all these functions. Just see a simple code, what it says. What is this TF? What's the meaning of this particular variable? Just say this one, TF underscore IDF underscore vector. Here we created an object, TF underscore IDF underscore is an object. We created a variable TF underscore IDF underscore VECT. Basically, I can say it's a variable. Just see, TF-IDF factorizer, we already discussed. n-gram underscore range equal to 1, 2 means we will construct unigrams as well as bigrams. Time being, just forget about this one. Min underscore df, I will discuss in my future natural language process classes. This is fit. We know what is fit. We already discussed what is fit. Now, if I print this one, what happens? Just see the output. What's the meaning of this particular output? Some sample features. What is this some sample feature? This is some sample feature. Unique words in the corpus. This is anyway message, unique words in the corpus. How will I get? TF-IDF underscore vect. This is my object name. TF underscore IDF vect is my object name. Get feature underscore names. I already explained in my previous slide. Just I am displaying 0 to 10. I am slicing. I am applying slicing and I am displaying these feature names. Which features I am getting? This ability, it is a unigram. Able, 10 features I am displaying, isn't it? The able find, this is bigram. This is bigram. Whereas able is unigram. Able get, it is bigram, isn't it? Absolutely delicious, this is bigram. Absolutely love, this is bigram. Absolutely no, this is bigram. According, it is unigram. That's what it says. Why? Because your n-gram underscore range is 1 comma 2. Just I am displaying features. I am slicing. Print this one means you are printing equals sign 50 times. Nothing more than that. It's simple and straightforward. What is this? Final underscore TF underscore IDF. Transform function. I already discussed what is transform function. Pre-processed reviews. What is pre-processed reviews? We discussed in our previous lectures. Type. What is a type? Basically, it create a sparse matrix. Yes, it creates a sparse matrix. The shape of out TF-ID vectorizer. What is the shape? What is the shape of this vectorizer? This is 4986. What does it mean? There are 498, 1, 2, 3, so on. There are 4986 rows. And how many columns? 1, 2, 3, so on. There are 3144 columns. That's what it says. Number of unique words including both unigrams and bigrams. How will I get? Number of column names only, unique words, isn't it? How many columns are there? There are 3144 columns. Therefore, there are 3144 unigrams and bigrams. This code is simple and straightforward. Anybody can understand this code. I will show you the same thing in Jupyter Notebook in my next lecture. Thank you very much.